So today our next topic is the centripetal force. As you guys all know, in the previous video we discussed about centripetal acceleration, and this is the centripetal force. What does it mean? It means centripetal, as you guys all know, in the previous video I told you guys that it means that it toward the center of circle. For example, I'm having this circle, okay, and as you guys all know, this is having this is center. Here you can see that this is the velocity 1, as you guys all know. In previous video discussed about detail velocity 2, velocity 3 and velocity 4 of object. Okay, so here you can write here that F centripetal force. So the centripetal force is basically what? The centripetal force is toward the center. This is what? This is toward the center. So toward the center, the force that is, you can say that keep an object moving along of a circular path is called centripetal force. So the direction of a body in a centripetal force is toward the center. The force that is acting toward the center of any object, that is called a centripetal force. Without centripetal force, circular motion is not possible. Okay, so if centripetal force is there, which means there is a circular body. Okay, so direction is what? Toward the center of the circle. Now if you want to find the magnitude, this is a vector quantity, so this is having a vector quantity, so this is having a magnitude and the direction too. So we have finding a direction that is towards the center. Now let's talk about the magnitude of a centripetal force. Okay, so this is this. So here you can see that this is there, for example, a string. Okay, and this is having a velocity 1, velocity 2, velocity 3 and velocity 4, and this is having a force centripetal force that is toward the center. So according to the second law of motion, because there is force, so according to the second law of motion, that is F is equal to ma, so we are finding what? Centripetal force. So I can write here centripetal force is equal to centripetal acceleration. This is what equation number 1. So here we were having a formula in the, as you guys all know, that AC is equal to what? As you guys all know, the centripetal acceleration is equal to the v square upon r. In the previous video we discussed about. So FC, that is centripetal force, is equal to the, here you can see that we are having a FC, so we can write here that the mv square upon r, okay. So here we have just put in the acceleration formula, v square upon r here. Okay, FC is equal to m, AC is equal to the this, so we have put it here, this. So this is the first formula of centripetal force. Now we have finding a 3 formula, as you guys all know. In the centripetal acceleration, we find a 3 formula of the centripetal acceleration, that were v square upon r. This is the first formula. Second, we were having centripetal acceleration is equal to r omega square, and third one we were having a centripetal acceleration of 4 pi square r upon pi. This is the third free formula. So from first formula of the centripetal acceleration, we have found the formula of the centripetal force. Now from the second formula of the centripetal acceleration, we will find the centripetal force formula. So we are having a second formula, that is AC is equal to r w square. So we are having a formula that is the AC, so we are having a formula that is, you can see the FC is equal to m, okay, and we are having the AC as a rw square. Okay, so this is the second formula of the centripetal force. Okay, so we have put this one formula into the FC is equal to the MAC. As you can see, FC is equal to same, M is equal to same, or AC is equal to RW square, so we have put it RW square as a AC. So this is the second formula. If we talk about the third formula, so we are having a third formula of the centripetal acceleration, that is AC is equal to the 4 pi square upon r upon. So we are having a first formula, that is FC is equal to MAC. Okay, So Fc is equal to m, and here we acceleration as the 4 pi square upon 4 pi square radius upon pi. So we can write here that the m multiplied by 4 pi square r upon you can say that the we having that pi, not pi, this is t, sorry, this is t, sorry, so this is t. Okay, so t square. So we can write here that, so we are having a formula that is Fc is equal to, here this is here it is multiplying, so rearrange this is m 4 pi square mr upon t square. So that is the third formula of the centripetal force. Okay, first formula, second formula, and third formula. We have derived these all formula just from the three formula of the centripetal acceleration. Okay, so this is the force, centripetal force, which is toward the, you can say, the axis. Okay, now let's talk about the centrifugal force. Centrifugal force is just the opposite of the centripetal force. It was what, toward the center, it is the away from the center, away from center. How? Let's see. Away from the center, for example, I'm having a circle here. Okay, and the, as you guys all know, the centripetal force was toward the center. This is away from the center. The force which is away from the center, that is called the centrifugal force, and this is the opposite of the centripetal force. So we are having a first formula of the centripetal force, that was Fc is equal to mv square upon r. In just this formula is same, just the minus sign is there. Why minus sign? Just because of the away from the center. So this is the formula of the centrifugal force. So today in this video we discuss about the centripetal force as well as the centrifugal force. So now this chapter is ended. In the next video we discuss about the next chapter, that is the chapter number 5.